In your data model, you may have created two tables that are joined in a many-to-many relationship. If that's the case, now is the time to resolve that into a format that can be implemented in the database management system. The most common example of a many-to-many relationship is the case of a class schedule, which includes a table for storing information about students and a table that stores information about various classes that are being offered. We'll note that each student could take between 0 and several classes, and each class would have several students enrolled. Thus, a many-to-many relationship exists between these two tables. This accurately represents the real-world situation we're trying to capture, but in order to actually create this in a database, we need to create an intermediary table that sits between the students and classes tables that further describe the interaction and allows us to exactly see which classes each student is taking, and, going the other way, which students are enrolled in which class. We'll do this in a process called decomposition. Here's how it works. First, take the primary key columns from each of the original two tables and make copies of them in a new table called a linking or junction table. In our example, we'll borrow the student ID column from the students table and the course ID column from the courses table. We'll give this new table a suitable name that represents the intersection of this data. Some people like to combine the names of the two original tables, creating something like students courses or courses students. This easily identifies the new table's position in the flow of data. Other suitable names might better describe the interaction. Something like schedule or roster might also make sense. In this case, I'm going to stick with students courses. The two columns we just copied in combine to create a composite primary key for this new linking table. This creates a situation where each student can only take a particular session of a course a single time and can't accidentally be enrolled twice for the same class. Each component of the key then gets related back to the original tables in a pair of one-to-many relationships. The student ID gets related back to the students table, and the course ID gets related back to the courses table. Now we can create any additional fields in this linking table that further describe the unique pairing of a student and a course. For instance, a final grade column is specifically about a student's performance in a single course. It's a perfect attribute to store in our new linking table because it isn't really about just the student, and it definitely isn't about just the course. So the junction table will store a unique pairing of student ID and course ID in each record. Most students will appear lots of times, while brand new students won't appear at all in the linking table. The nice thing about this arrangement is that it doesn't prevent a student from being created in the students table that hasn't yet registered for a class. And courses can be created in the course table even though nobody has yet registered. As soon as a freshman student registers for their first course, however, a new record in the linking table will be created that identifies their student ID and the course ID they registered for. Now, as we read the diagram, we can easily identify all of the courses that a particular student has taken and easily get a roster of students registered for a particular course. This is how a many-to-many relationship gets represented in the DBMS. In reality, they become a pair of one-to-many relationships that pass through this intermediary junction table. In preparation for moving our design into the production phase, we need to accurately resolve all of our many-to-many relationships. To do this, you'll print out a new table design worksheet for each many-to-many relationship in your data model. Give the new table a suitable name, and fill in the names and data types for the composite key columns by copying the name and data type from the two original tables. Finally, think through your original business rules and interview sessions to determine whether there is any additional information that is uniquely captured by this intersection of values, and add them back into your data model diagram.